a company like this doesn't have a specific end date. So we actually expect the cash flows to continue on in perpetuity. What we generally assume is once we get to time T plus S, right? So once we get to the point in time where a company stabilizes, T in our example here was 5 years because we expect 5 years until a Series A would exit. We generally assume that the length of the rapid growth phase, so the parameter S, most common assumption is 5 years. That's what I assumed here. In practice, we see estimates between 3 to 7 years for that. But by far the most common number is 5 years. So that means 5 years plus 5 years, company stabilizes at time 10. We generally assume that cash flows after the stabilization date grow at a constant rate every year, where that constant rate is equal to the growth rate, the long-term growth rate of our market. So we had assumed in the problem that the long-term expected growth rate for the virus screening market was 3% per year. So what that means is along with these numbers here, we also estimate, we're forecasting that the cash flows for this company are going to grow by 3% per year every year, starting at time 10. So that means at time 11, we would expect the cash flow equal to, right, the time 10 cash flow grown by 3%, which would be 224.34 million. And then that number would keep on growing by 3% per year. So how do we go about valuing the startup in light of these forecasts? So there's two approaches that we see used in practice. One is simpler, so I'll introduce that one first. It's called discounted cash flows with the VC method. Now maybe I should mention one thing about what I mean by the VC method. If you recall, when we did our exit comparables-based valuation, right, we had a 4-step procedure for valuing a startup, right? We first found exit comparables. We picked an attribute for doing our multiples-based valuation, like revenue. Then we estimated an exit value conditional on success for our startup. And then in a final step, we went from exit value conditional on success to value of the company today by just taking exit value conditional on success and, loosely speaking, discounting it using the VC discount rate, which was a number that was substantially higher than the true discount rate for the company, right? If you recall, we had shown that the value of D actually would pick up, right, was given by this expression here. So this VC discount rate was picking up the true discount rate for the startup, but also other information like anticipated dilution, probability of success, fees charged by the general partners of a venture capital fund to the limited partners that provide capital to that venture fund. This last step that we had discussed, right, step 4, in terms of practitioner lingo, this is sometimes called applying the VC method, which is just a quick way to go from an exit value conditional on success to a value of the company today. In an exit comps-based valuation, we got our exit value conditional on success using this comparables approach. What we're going to do in our DCF-based application of VC method is instead of getting our exit value conditional on success off of exit comparables, we're going to get it off of forecasted cash flows. And we're going to do this in 2 steps. First, we're going to try to estimate, well, given our forecasts, right? So given our estimated cash flow forecasts, these ones right here, what would we expect the value of the company to be at time 10, just after it's generated this 217 million in cash flow? So that's the first question we're going to answer. Conditional on success, what would we expect the value of this startup to be once it stabilizes? There's a practical reason for asking that question, which is we would expect its value at that point in time to just be the value of a growing perpetuity. Because once the company stabilizes, we expect it to have a constant growth rate going forward. Sorry, a constant discount rate going forward. Right? That was this assumption that once you stabilize at time t plus s, from that point on, you have a constant discount rate forever because you've now matured. But in addition to that, we also assume that we're going to have a constant growth rate of our cash flows thereafter as well, right? So once the company stabilizes, we expect, in the case of SecureTech, a constant 3% growth rate per year because the overall industry is growing by 3%. SecureTech is not capturing any additional market share or losing market share. So it should be growing at a very similar rate to what the overall industry is growing at. And so given those two observations, we can get our estimate of the value of this startup once it stabilizes, so at time t plus s, conditional on success, just given by this growing perpetuity formula. So in the context of SecureTech, this is a pretty straightforward calculation. All we do is we take our cash flow, our forecasted cash flow at time t plus s, we grow it by one period using the 3% long-term growth rate of the industry to get 224 million. That's our estimated cash flow conditional on success for SecureTech at time 11, which is one period after stabilization, the next period once the company stabilizes. Right, so all I do is I take cash flow at time 10, grow it by the constant stable growth rate of cash flows for this startup, which again, we just obtained from an estimate of long-term industry growth rate for SecureTech's industry, and divide that by our stable growth discount rate minus 3% because it's a 3% growth rate in cash flows. And that gives us our estimate of value at time 10. In terms of terminology in my slides, TV means a terminal value. So that means, right, this value here doesn't incorporate everything that's happening from time 0 to time 10. But as of time 10, it picks up the fundamental value of everything that's happening with this company afterwards. So time 11, time 12, time 13, so on and so forth in perpetuity. And so that gives us 2.9 billion. So the way we interpret this is conditional on success. We would expect SecureTech to have a value 10 years from now equal to about 2.9 billion. So this is the first step that we do when we're using DCF combined with VC method to get the value of our startup. Now, of course, this value does not pick up everything that's happening at the startup before and on time t plus s. So the next step is that we estimate an exit value conditional on success, right? This is a value after S periods after exit. What do we expect the value of the startup to be at exit, so at time t? Well, what we'd want to do is, take the discounted cash flows of the cash flows associated with the startup at time t plus 1, t plus 2, all the way up to t plus s. We would also want to include t plus s plus 1, t plus s plus 2, so on and so forth. But an easy way to incorporate everything that happens after time t plus s is to use the terminal value that we obtained in our earlier step. Right, so the value at time t would be the discounted value of the cash flows from time t plus 1 to t plus s, plus the value of that company at time t plus s, discounted for S periods as well. Now, one thing to notice is in step 1 and step 2, we use different discount rates. So we use our stable growth discount rate for discounting every point in time after time t plus s. But between time t and t plus s, we discount at the rapid growth discount rate, because after time t plus s, this is reflective of the risk of the company. But between time t and t plus s, we've got actually a higher level of risk for the company because it's still a riskier high growth company.
And so,
yeah,
sure. Why in 23 the denominator is to the exponent of s?
Right here?
And then on the right, yes, that one.
Yeah, so these two.
No, the other one on the right, yes.
Okay, so one way to think about this is, one way to think about the value of this company at time t is if you own the company at time t, you would get this cash flow at time t plus 1. You would get this cash flow at time t plus s. Now let's assume that you, right after this cash flow was paid to you, right, 1 instant later, so it's still at time s, you would sell the company. You would expect to sell the company for this much because that's how much it's worth at time t plus s. So what would be the value of that at time t? You sell in s periods, which is why I discount by s. You receive this cash flow in s periods. You receive this cash flow in 1 period.
Right, okay.
So that's one, right? But one thing I should actually clarify is, notice that for the cash flow at time t plus s plus 1, notice that the t plus s plus 1 cash flow, you discount it at the rapid growth discount rate for s periods, and you only discount it at the stable growth discount rate for that 1 additional period between time t plus s and time t plus s plus 1, which is why, notice here, I still discount by RRG instead of RSG. So just keep in mind, like, you'll use in step 2, RRG also for discounting this, discounting this terminal value.
Okay, but in 23, the numerator is t plus s, but if you use 24 in it, you have t plus s plus 1, and the denominator is to exponent of s, so that's a little bit confusing.
Sorry, can you?
So in 23, the numerator is at time t plus s.
Yeah.
But you can use 24 to replace that. But that's a cash flow at t plus s plus 1.
I guess, okay, so maybe let me explain. Sorry. So what I'm basically saying is, right, so V t plus s, conditional on success, is equal to what? Cash flow t plus s plus 1 discounted by stable growth rate for 1 period, plus cash flow t plus s plus 2, 1 plus RSG for 2 periods, so on and so forth forever. This is just NPV, right? But since we assume a constant growth rate, this is equal to cash flow t plus s plus 1, 1 plus RSG, plus cash flow t plus s plus 1 grown by the stable growth rate for 1 period, RSG squared, 1 forever. This is just a growing perpetuity.
Mm-hmm.
And so this is given by cash flow t plus s plus 1 over RSG minus GSG.
Right.
We could also write this as cash flow t plus s grown by the stable growth rate for 1 period over RSG minus GSG, right? Mm-hmm. Because we expect, whatever we estimate as our cash flow time t plus s, if we grow it at that stable growth rate over the next period, that should give us our estimated cash flow in the following period. And so then I just basically said, look, value at time t, conditional on success, should take into account everything that happens after after time t, so the expected cash flow at time t plus 1, now discounted by the rapid growth discount rate, because t plus 1 is during the rapid growth phase, all the way up to cash flow at time t plus s. This is just an NPV formula for s periods, because this is s periods after time t. And then I'm just assuming after this cash flow, the value of everything that's left would be given by this expression, which was obtained here. And then since that's s periods after time t as well, I just discount my RRG for s periods as well.
Okay.
So that's how I obtained those numbers. So I just basically go and implement those calculations in Excel. So in my Excel spreadsheet, the first step is calculated here. All I did is I took my estimate of the cash flow at the stabilization date, t plus s, grew it by 1 period, and discounted by long-term discount rate minus that same growth. So notice the 0.03 and the 0.03 here are the same. Then I estimated a terminal value at time 5, which is the exit value conditional on success, by taking the NPV of the cash flows from time 6 to time 10, but now using the rapid growth discount rate, plus the terminal value that I estimated in the first step, discounted also by the rapid growth rate for, in this case, 5 periods, because my estimate of S was 5 periods. And so what do I have so far? So far now I have an estimate of what the exit value of Secure Tech will be, conditional on success. So that's about $1.8 billion. Now, of course, this is not the value of the startup, but again, using the same approach that we had used in our last step of exit comparables, we can take exit value conditional on success and just divide it by 1 plus d to the power of t, where we get our estimate of d just using our VC data set, right? So for a typical Series A, the value of d is 0.6. So I can just go and use this last step to get the value of startup right now. Just take
Professor, just one question, just more with regards to labeling. So for the range K21 to K23, basically we're looking at VT plus S, VT, and V0, correct?
K21. Okay, so so this number here is, this number here I'm not going to be using yet. I'll refer to it a little bit later. So far we've just done these two calculations, right? Get the value of Secure Tech at time 10, assuming things are successful.
Which is VT plus S, correct?
Exactly. This is VT plus S. Exactly. This is VT.
Perfect.
And then what I do is I plug in VT into my step 4 formula from exit-based comparables, right? Which just basically means take the 1.8 billion and divide it by 1 plus 0.6 to the power 5. Why? Because 0.6 is the usual VC discount rate that we use to go from an exit value conditional on success, which was this number. This number is just I just put the number twice. To the power of 5, because on average, a Series A startup exits in 5 years. So this is one approach that we can use to get our valuation for the startup. One thing I should highlight is that this valuation here is a value of the startup using operating cash flows, right? Because these are cash flows from operations. And so as a result, if the startup also has some cash, we should take this value and add to this the amount of cash that the startup has. So if SecureTech also had an additional $20 million, then our valuation of SecureTech would not be 172 million. It would be 172 million plus the 20 million in cash that it has. So 192 million. So just keep in mind just to go back to my slides here. This final step value, this is the same thing as step 4 from my exit comparables slide. This is a value not including the cash that the startup has. And also, like, if the startup is raising money right now, so let's say the company has 20 million, but it's raising another 15 million, then we would actually need to take this value and add both the 20 million the startup had before it raised cash, plus the 15 million that it just recently raised as cash. So maybe I should have said in this formula plus cash at time 0, which is cash post fundraise if the company is raising capital. Not an issue in the example that I'm discussing right now for SecureTech, because I don't mention anything about cash. If I don't mention cash, assume the company has no cash. But if the company has cash, just add it to this number from the VC method calculation here. Now, one thing I'll point out, which might seem unusual to some of you, is that if you look at what we did to get this calculation, right, notice we used all our estimates of cash flow from time 11 onwards in our terminal value calculation at time 10. So VT plus S, you want to reconcile with the notation that we have in my slides, right? This calculation here considers all the cash flows from time 11 and beyond. And in our calculation here, we considered all the cash flows from time 11 and beyond by referring to this calculation here. And we directly considered all the cash flows from time 5 to time 10 by taking an NPV of those cash flows. But notice, in getting this number here, we actually never used our cash flows from time 0 to time 5. So if you look at each step, we never actually use these numbers. In fact, we can see this in our formulas here. Notice we use all our cash flows beyond time t plus s in this calculation. We use our cash flows from time t plus 1 to t plus s here. But there's nothing in my formulas here that say cash flow 1 all the way up to cash flow t. Does that mean we're completely ignoring those cash flows? Well, if yes, right, if we were completely ignoring those cash flows, then you might think, oh, well, we must be overestimating the value of the company because those cash flows are all negative. So if we're ignoring them, factoring them in should reduce the value of the startup because the company's losing money from time 1 to time 5. Now, answer to this question is that we're not actually completely ignoring these cash flows. We're just indirectly accounting for the fact that this company has negative cash flows from time 1 to time 5 via our use of the VC discount rate, this value D. Right? Because if you recall, the value D, back to our topic, this value D, right? How was it obtained in practice? It was using this formula, and this value D picks up anticipated future dilution between now and exit. Well, why do you have dilution of current owners of a startup? It's because the company needs to raise additional capital in the future to cover its expected future negative cash flows. So when we use the VC method, we kind of indirectly incorporate the negative cash flows from time 1 to time 5 or time 1 to time t. via our use of the VC discount rate D. Now, the thing is, this value D is assuming that the startup will have a normal level of dilution from now until exit. In other words, these negative cash flows are, loosely speaking, typical for a company of SecureTech size, right? So a typical company of SecureTech size would lose roughly this level of money from time 1 to time 5. If that's not true, if SecureTech is expected to lose more than the average amount of money than a typical Series A startup would from now until exit, or lose less, then by using this rule of thumb value of D that we obtain from typical VC investments, we would not be correctly accounting for the negative level of cash flows for a startup. So this approach that we just covered, right, the DCF with VC method, where we first compute value of the startup conditional on success at time t plus s when the startup stabilizes. Then as step 2, calculate exit value conditional on success for the startup, and then plug into the VC method, right? This procedure is only likely to give us an accurate or a reasonable value for V0 if our startup is a typical startup at this stage of funding. Again, general rule of thumb that I look at here is if the company is expected to not lose as much money as a typical startup at its stage of funding would, or is expected to lose more than an average level of cash flow than a typical startup, then I would be reluctant to use this approach. One example where I would expect a startup to lose more than an average level of cash flow would be in the case where we're valuing a company that's blitzscaling. So if a company blitzscales, if you do this final step calculation here using the rule of thumb value of D, you're likely to overestimate the value of the company, because a blitzscaling company is expected to lose more money than a typical startup from now until exit. And so when you use this rule of thumb value of D, you'd be under accounting for the expected level of dilution that this blitzscaling company would have. We expect a blitzscaling company to get diluted more because it needs to fund excessive negative cash flows early on. Why? Because it's scaling aggressively when it doesn't have attractive unit economics. So it's expected to be losing more money in the short run as it aggressively scales with bad unit economics. So again, only do this calculation, right? Only use this method if you think your startup is relatively typical for a startup raising a given round of funding, right? So in this case, that it's a relatively typical Series A company. So what do you do if you think the startup is not a typical startup at this at its round of funding? In that case, then we want to be a little bit more rigorous in modeling our DCF valuation. Let's think about what we've done so far. So what we have here is, sorry, an exit value conditional on success. Sorry, I'm just trying to highlight something here. Exit value conditional on success, right? We could also estimate a value at time 0 conditional on success by directly accounting for the cash flows that we have from time 1 to time t, right? So we could do an additional step. So do the same first 2 steps that we did in our first approach, and now do a third step where you take the terminal value, the exit value conditional on success of the startup, discount it at the venture period discount rate, right? Remember, in this step here, we had used the rapid growth discount rate. In this step here, we had used the stable growth discount rate. Now in this third step, we're using the venture period discount rate because we're looking at the value of the company at time 0 when it's still in its venture period. And we now directly account for those negative cash flows from time 1 to time 5 and discount those at the venture period discount rate as well. Notice if we do this calculation, we get 523 million, right? So this is clearly not an appropriate valuation for this startup, right? It's such a different answer than what we obtained in our first DCF valuation, which was DCF with VC method, right? 172, 523. So the question is, why is this number not an accurate valuation of the startup of SecureTech? Well, it's because this value only considers the case where the startup is successful. So what we should do is we should balance out what is the value of the startup if it's successful versus what's the value of the startup if it's not successful, if it's a failure. Again, just connecting with notation that I used in note 1 of part 2 when we did our comparables-based valuation. P is the probability of success of a startup. And again, I've given us numbers on what those values typically look like for a Series A company. Sorry about that. Let me just reshare the screen here. Right, so a typical Series A company has a 51% probability of a successful exit eventually. Right, so we should say, look, what we found is the value today of the startup is 523 million. If I think it was 523 million, 523 million. If the company eventually becomes a success, but today we don't know that it's going to become a success. So we need to account for the possibility that it can either be a success or it can be a failure. So in addition to estimating a value today, if the company eventually becomes successful using equation 26 here, we also want to balance it out with a value of the company if it ends up failing. Right, so we should take, for a typical Series A, as I said, 51% probability of success. We should take 51% of the 523 million plus 49% of some estimate of what the exit value of the startup conditional on failure is. Now, how can you obtain an exit value conditional on failure for a startup? Well, one estimate might be to just plug in a value equal to 0. If the startup fails, it generates no value. Would that be an accurate estimate? That would likely be too high an estimate of value condition. Sorry about that, conditional on failure. Because we would expect that a startup that eventually fails actually has negative value today, because between now and its eventual failure, we would expect the startup to be losing money. So it would actually destroy value. So the question is, how negative would we expect this value to be? So right, so what we did here is we basically did a DCF. So in equation 26, we did a DCF of the expected cash flows of the startup, assuming success, right? So S. Now what we'll do is we'll estimate cash flows for the startup over time, assuming eventual failure. So how should the expected cash flows of a startup, right? So value of startup conditional on failure. So how can we obtain that, right? We would, again, want to do, sorry about that. Value conditional on failure should be what? Expected cash flow at time 1, conditional on failure, discounted by the venture period discount rate for 1 period, plus expected cash flow if the startup eventually fails, discounted by 2 periods, all the way up to, I'm actually just going to put up to cash flow at time t, conditional and failure, 1 plus RVP to the power of t. I'm not going to add additional cash flows because if a startup fails, by definition, we know it's going to be failing before the exit date, right? Because success means that you have value, you continue to have a positive value at the exit date so that you can exit at a positive value. So by definition, cash flow t plus 1, cash flow t plus 2, conditional and failure, so on and so forth, are all equal to 0, because if you fail, you'll fail by the exit date. If you haven't failed yet, then you're able to successfully exit at a positive value, either by an acquisition or by an IPO. So now the question is, what do we expect these cash flow numbers to be? Right? Well, it kind of depends, right? So what is cash flow at time little t, conditional and failure, where t is between 1 and time t? Well, it depends. There's 2 scenarios, right? Already failed at time t and haven't failed at t. Well, if you've already failed at time t, then your cash flow is 0 because you're no longer operating. You've already failed, so you generate no cash flows thereafter. Now, what would be a good estimate of your cash flow at time t if you haven't failed yet? So I'd argue that that number should be equal to the cash flow at the same point in time, conditional on success. Why? Because if different, then you can distinguish between success and failure at t. And if you can distinguish between success and failure at time t, then you should take the failure case and just make it fail at time t, but we've assumed that we haven't failed at time t here. Right, so if this number conditional on surviving until time t was not the same as this, right, we would have a logical inconsistency on the part of continuing to fund and allow a startup to succeed. And so now what I'm going to do is I'm going to define a parameter QT. That's going to be the following. So conditional on failure, what's the probability that a startup is still alive at time t? Well, if we know these numbers, then the expected cash flow at time t, conditional on failure, is just QT times expected cash flow conditional on success, right, plus 1 minus QT times 0, which is just QT times cash flow t plus S, right? With a probability QT, this cash flow is given by this number. The rest of the time it's given by this. Well, what's the average cash flow? It's just given by this expression. Now, why is this expression useful? This expression is useful because I also have historical data on QT. So in the same handwritten document that I provided that gives you these summary statistics from the historical VC data set on investments for values of D, P, discount rates, expected future dilution, so on and so forth. In addition to that, I also have data on these Q parameters using this historical data set. So the way to read this table right here is if you look at a seed stage investment, even if in the scenarios where that seed stage investment eventually fails, the company survives for one period always, because it's raising capital. So since it raises capital, it's going to be able to survive at least over the next year. So 100% of the time, a seed stage investment that eventually fails survives at least for 1 year. But only 43% of the time does it survive for 2 years. 32% of the time it survives for 3 years. And once we get to time 6, where time 6 is the expected exit date for a seed stage investment, it by definition doesn't survive. And I have similar numbers for Series A. So a Series A startup that eventually fails would survive always for 1 period, 75% of the time for 2 periods, 30% of the time for 3 periods, and 15.1% of the time for 4 periods. So how can we use this data to get an estimate of the value of SecureTech conditional on failure? Well, since SecureTech is a Series A, we're going to use these numbers. Again, these numbers are obtained from real world data. So I'm going to use these numbers to get each of these cash flows. I've done this in my spreadsheet right here. So these are my cash flow forecasts for SecureTech in the failure case. Right, so here is the data that I put in the handwritten document. 100% of the time, a failure survives for 1 period. A success generates minus 11 million. Conditional on survival at time 1, a failure would also generate on average minus 11 million. If it didn't, you'd be able to separate success versus failure at time 1, and you wouldn't let the failure cases continue to survive at time 2, 3, 4, so on and so forth. So 100% of the time, you get that same 11 million. So you'll notice I take this QT parameter and multiply it by my cash flow forecast conditional on success. So on average for a failure, I also lose 11.1 million in 1 period. But on average, how much do I lose in 2 periods? Conditional on failure, I lose 29 million rather than 38 million. Why? Because 75% of the time I lose 38 million, but the remaining 25% of the time, my startup has already failed. When it's already failed, it's not operating anymore, and it doesn't generate any cash flows. So 75% of minus 38 plus 25% of 0. That gives us $29 million. What's the average cash flow at time 3 conditional on failure? Well, 30% of the time you survive for 3 periods, and in that 30% of the time you lose on average 116 million. And finally, 15% of the time you survive 4 periods and lose 241 million. On average, from the perspective of time 0, that's an average loss of minus 36 million. And then after time 5, because the company has exited, this company will have already failed, and so it generates no cash flow thereafter. And then all I do is I take the NPV of these failure cash flows and discount it also by the venture period discount rate. So that gives me a number equal to minus 76 million. So what have we established so far? If we knew that the company would eventually succeed, it would be worth 523 million. If we knew that the company would eventually fail, it would be worth minus 76 million. If we just take P, probability of success, times this number, plus 1 minus P, probability of failure, times this number, that would give us $229 million. So I do this calculation here. This is in my slides as well. Right, so this is my calculation right here. Right, I took 523 million, value today of the startup if we know the startup is going to succeed, minus 76 million, value of the startup today if we know it's going to fail. We probability weigh those two outcomes because we don't know which of the two scenarios is going to happen today yet. So 51%, 49%. And that gives us a value on the start. Now the question is this an accurate valuation for Secure Tech right now? The answer is no, because we also need to incorporate the fact that the entity that actually makes the investment into the startup, which is the limited partners of a venture fund, venture capital fund, have to pay fees when they make this investment to the general partners of the fund. And since they know they're going to be paying fees, they wouldn't be willing to pay this whole 229 million in value. They would have to kind of reduce that valuation in order to make up for the fees that they know that they're going to need to pay that are not being modeled here. So how do we model the fees charged to investors who invest in a startup, right? So limited partners of a venture fund. Well, we can take this value. This is a value without fees. I'm going to add in cash. That's going to convert this value without fees, which doesn't, as I had discussed in our prior slide, that does not incorporate the cash, right? So here I would also say plus cash 0. And then I need to scale this number down to factor in all the fees that a venture fund charges. What is the scale down factor that we need to use? We'd actually establish what this relationship should be in note 1 of part 2 of the course when we discussed exit-based comparables valuation, right? Which is that this factor here needs to pick up the fact that general partners of venture funds charge carry fees to the limited partners of a fund and charge management fees. So if I don't want to go into all the details here, but if we compute this expression right here, so 1 minus C times 1 plus the venture period discount rate, in this case 14.75%, to the power of T minus 1 over 1 plus that same venture period discount rate to the power of T, and then divide that by 1 plus management fee times number of years that we expect the management fee to be charged. That gives us a value of the company that accounts for success versus failure while directly modeling the cash flows from time 1 to time T. Also picks up the possibility that the company is cash and is raising capital, but also adjusts for the fact that the value should be lower because of the fees associated with making an investment in a startup. And so this last step here that's given by equation 28, I calculate in my spreadsheet down here. Just in terms of lingo, LP share is my estimate of this parameter fee. Again, how did I obtain that? I take 1 minus the carry fee. The standard carry fee to assume for a venture fund is 20%. So that's why I use the 20% here. The standard management fee for a venture fund is 2%. So that's why I use the 2% here. But I just take, all I've done here is I've calculated the formula for this parameter here. And then I take this valuation. Again, right now I'm assuming that in both this calculation and this calculation, I'm assuming that Secure Tech doesn't have cash and isn't raising capital. But I basically just take fee times this number. That's the calculation of this expression under the assumption that the company has zero cash. And that gives us a number equal to 188 million. So notice in this specific example, Secure Tech, whether we use the first approach that I discussed or the second approach, right? So this is DCF with VC method. This is our eventual answer for the second approach, which I refer to as fully-fledged DCF. I call it fully-fledged because we're incorporating a lot more information in doing this valuation than in the prior valuation. General rule of thumb, this is an easier method to implement in practice because you need to make fewer assumptions. But the drawback is that you're assuming that your company is a relatively typical startup for this round of funding. Approach 2 is trying to be more rigorous and models more things directly. But in trying to be more rigorous, you need to make a lot more assumptions. And as a result, it can be more difficult to implement in practice. But if you can implement this well, it's likely to give you a more accurate valuation than this approach. But I would say in practice, this approach is used more often for valuing startups than this one, primarily because of its greater ease and simplicity of use.